Hey fellow problem solvers, Colfax Math here. Today I was going to do a short video on function notation and order of operations. It's really a great place to start a lot of math classes, both exact value, meaning paper and pencil, versus approximate with a calculator. A lot of people really understand a lot of big ideas, but get the answers wrong because they're using their calculator incorrectly with order of operations. I'm going to go over order of operations in some different functions and some function notation. So kind of everything in math is based on this idea of the Cartesian coordinate plane, where x is your horizontal axis, y your vertical axis. X is always your independent variable, y your dependent variable. You could have a linear graph, an exponential graph, an nth power graph, and whether or not it's a function, you could check that with the vertical line test. If you draw a vertical line anywhere on your graph and it crosses it in only one place, yes, it is a function, and therefore I could use the function notation replacing y with f of x. So the definition of the function is that for any given independent variable, there is only one corresponding dependent variable, and that's how that vertical line test works. So if I had a graph like this, and I were to draw a vertical line on this graph, I could see it crosses in two places. This is not a function. Therefore, I cannot use this f of x notation. Here, I draw that vertical line. It crosses in one place only. Yes, it is a function. I replace y with that function notation. So that's the first thing about function notation. This is just saying it is I've already checked it. It is a function. It's a model. And if I want to find a specific value in that model, I could say find f of 3. Wherever there's an x, I now replace it with a 3. So 3 times 3 plus 5, and I get f of 3 is equal to 14. I could also do a composite graph where I don't want to find f of 3. I want to actually input another model like g of x. I could say f of g of x. That is saying wherever there's an independent variable x, replace it now with g of x. So I have this 3 to start with. In the place of x, I place g of x, which is x squared. So that x squared goes in for that x. And then I still have that 5 at the end. So this is just evaluating a function given a value. And this is a composite function right there. Okay, then the next step I was going to look at is inverse functions. The way you write inverse function is f to the negative 1 of x. What that is saying is flip the y's and the x's around. So wherever there's a y, put an x. Wherever there's an x, a y. So f of x and y are the same. So my original function is y equals 3x plus 5. If I am looking for the inverse, I swap my x's and y's. So I have x is equal to 3y plus 5. Then I have to isolate my y. So I subtract 5 from both sides. And then I divide both sides by 3 to get y by itself. So now I have y by itself. So y is equal to 1 over 3x minus 5 over 3. So the inverse function of f of x is equal to 1/3 x minus 5/3. So again, just a review on functions, what they are, independent, dependent variable, a little bit of function notation, how to evaluate a function, how to find a composite function, how to find an inverse function. Now we're going to look at order of operations for a function. I'm going to look at trig functions in that case. Okay, now let's look at order of operations, both what I call going forwards and backwards, meaning given a value for x, solve for y, and then the next problem is given a value of y, solve for x, and order of operations is going to be really important here. So what I'm saying is f of x is this function. I've checked that with the vertical line test. I've replaced y with f of x because I know it's a function. Now I'm saying evaluate that function when x is equal to 180. So I plug 180 in here, right? So this is in degrees. It's going to give me f of 180 is 5 sine 180 minus 90 degrees. Now remember PEMDAS is parentheses, exponents, multiplication or division from left to right in order, then addition, subtraction. So I got to do my parentheses first. So this is equal to 5 sine 180 minus 90 is 90. Then this whole thing, even though there aren't parentheses around it, is really still in parentheses because it is a separate operation. I am performing the sine function on that 90 degrees. I might know that sine of 90, I can figure that out as an exact value problem in my okay, so I have f of x is equal to 5 sine of x minus 90 degrees. This time instead, I'm going to say a different problem. Find x, find my independent variable when f of x is equal to 4. Okay, so this is a different problem. It's probably going to be an approximate problem with my calculator. So I have to use my calculator. I am in degrees, so I'm in degree mode with my calculator. This is saying take that 4 and plug it in here. So I have 4 is equal to 5 sine x minus 90 degrees. I still use the same order of operations, but what's different here is I am going backwards, meaning I am isolating my independent variable. So in my first case scenario right here, I am given a value, an independent variable, and I plug it in and I evaluate this. In my second case scenario, I'm given a dependent variable asking how do I isolate x, how do I get x by itself. So I still use PEMDAS, but I reverse the operations. So I had to do the exponents first, but now I'm going to do them last, right? So I'm trying to get x by itself. I'm going to divide both sides by 5. I'm trying to get this by itself. 4 divided by 5 is 0.8. These 5's have canceled. That's equal to sine x minus 90. I can't get in here until I get rid of that sine. The way I get rid of a sine is I take the inverse sine of it. So I take the inverse in functions, especially when using a calculator.